Hello everyone, welcome to Teacher Hanji's channel, and for today's tutorial, I will discuss about direct variation. Our objectives for these lessons are: first, illustrate situations that involves direct variations. Second, write equations of direct variation. Third, find the constant of variations. And fourth, find the unknown variables. Let me cite first some examples or situations that deals with direct variation. For example, a work may be paid according to the number of hours or days he or she worked. So the more days or hours they work, the more salary can receive during their payday. While the less hours or days they work, the less payment they will receive. Another example is the speed of a car and the distance traveled in a certain amount of time. The lower your speed, the lesser distance you can travel. So for our last example is the number of meat you bought and its weight. The more meat you had, the heavier its weight. While the less meat you bought, the lighter its weight. So these are some situations in which we can apply direct variation. Actually, there is direct variation whenever a situation produces pairs of numbers in which the ratio is constant. The statements y varies directly as x, y is directly proportional to x, y is proportional to x means that y is equal to k times x, where k is the constant of variation. To find the constant of variation, use k is equal to y over x. And for quantities x and y, an increase in x causes an increase in y as well. Similarly, a decrease in x causes a decrease in y. So that is the same with the example I've shown you a while ago. Now, let us move on with the following activities that involves direct variation. So let us express the following statement as equation of variation using k as constant. So number 1, the variable c varies directly as t. So the equation for this statement will be c is equal to k times t, in which the first variable given here, which is c, will be isolated to the left side, while the second given variable will be at the right side together with a constant or k. So let us have another example. Number 2, the OC of fish varies directly as its weight W in kilograms. So the equation for this statement will be C is equal to K times W, in which C is the first variable given in our statement and W is the second variable given to this statement, which is C will be written at the left side of the equal sign and W should be at the right side together with the constant term. Let us have the third one. An employee's salary S varies directly as the number of days D he has worked. So for this one, since our first variable is S and the second variable is D, then the equation of this variation will be S is equal to K times D. So that is how we write the equation of a given statement. So let us now have another activity. Given that y varies directly as x, using the table of values, determine the constant of variation and the equation of variation. So, in solving the constant of variation, like what I told you a while ago, the constant is equal to y over x. So, we simply substitute the values of x and y to our equation here to find the constant of variation. So, let us start with the first column. So, here we have 5 over 1, in which y is equal to 5 and x is equal to 1. For the second one, we have 10 over 2. From here, we have y is equal to 10 and x is equal to 2. Next, for the third one, our y is equal to 15 and x is equal to 3. Therefore, we have 15 over 3. And for the last one, y is equal to 20 and x is equal to 4. Therefore, we have 20 over 4. So let's now see one if possible. Let's try with this one. 5 over 1 is equal to, yes, 5. 10 divided by 2 is equal to 5 as well. 15 divided by 3 is 5. And 20 divided by 4 is 5. Therefore, from here, we conclude that the constant of variation of this table of values is 5. Now, let us get the equation of variation. So, since given here that y varies directly as x, therefore that is the same with y is equal to k times x, in which we know the values of our constant, which is 5. So, we simply substitute it to our equation. So, we have y is equal to 5x. And here is the equation of variation. So, let us have another example. Given this graph, let us find the constant of variation and the equation of variation. So the same with what we did a while ago, we just simply get the value of our k, which is equal to y over x. So from first column, we have 1 over 3, 1 for y, and 3 for the value of x. For the second one, it can be 2 over 6. The same, y is equal to 2 and x is equal to 6. So for the third one, we have 2 over 9. And for the last one, we have 4 over 12. So from here, let's find its simplest form. Since 1 is already in simplest form, then keep it as is. It is equal to 1/3. So if we simplify 2/6, we will have 1/3. Simplify 3/9, so we have 1/3 as well. And simplify 4/12, so we have 1/3 as well. So therefore, the constant of variation of this table of values is 1/3. Now, let us find the equation of variation. So again, given that y varies directly as x, we will use that equation. Y is equal to k times x, in which the constant is equal to 1. Therefore, substitute it to our equation. We have y is equal to 1/3 times x, in which that one will be the equation of our variation. So let us move on with another activity. Given that y varies directly as x, using the graph, determine the constant of variation and the equation of variation. So I have here the graph of direct variation. So remember that the graph of direct variation is a straight line that passes through the origin. So for example, this graph has a straight line and this line passed through with our origin 0, 0. Therefore, this is an example of a graph of direct variation. Remember that to find the constant and equation of variation, you must identify at least one point in the graph. For example, from this graph, we have the points 2, 6, we have points 4, 12, 6, 18, 8, 24, and 10, 30. Again, just pick one point from this graph. Another thing, we have here two options in finding the constant of variation and equation of a given graph. So the first one is through the equation itself. Y varies directly as x. So this one will be y is equal to kx. So what you need to do is just identify one point here, but for now, I'll be picking points 2, 6. And from here, I will substitute 2x here and 6 to y here. Therefore, I have 6 is equal to k times 2, which is the same with 6 is equal to 2k. So to isolate k here, we need to divide both sides by positive 2. Therefore, the constant is equal to positive 3. So here it is. The constant of variation is equal to positive 3. Now, let us move on with the equation of variation. So from our equation here, just substitute the value of our constant. Therefore, the equation of variation will be y is equal to 3x. So what is the other way on finding the constant and equation of variation of a given graph? So the other way will be finding the value of k using y over x. So if you notice, I have here the same graph as the graph that I used before. So let us check if we will arrive with the same answer. So from that activity, our constant is equal to 3 and the equation of variation is y is equal to 3x. Let us see if we will arrive with the same answer if I will choose other points than 2, 6. So from here, I will be picking 12. So this one. So I will substitute 4 to our x and 12 to our y. Therefore, constant will be 12 over 4. And 12 divided by 4 will be equal to, yes, 3. Therefore, the variation is equal to positive 3. So as for the equation of variation, just substitute k here to our equation. So we have y is equal to 3x. So that is how we determine the constant of variation and equation of variation. So this time, let us have another activity. Do as indicated. Number 1, y is directly proportional to x and y is equal to 7 when x is equal to 21. Find the constant of variation. So we have here y is directly proportional to x. Therefore, our equation will be y is equal to kx. In which to find the constant of variation, it will be equal to y over x. Since in our statement it says that 7 is equal to y and 21 is equal to x, therefore we have k is equal to 7 over 21. Simplifying this one, therefore our k will be equal to 1/3. And this is the constant of our variation. Number 2, z varies directly with w. And z is equal to 50 when w is equal to 40. Find the equation of variation. So in our first activity, you are asked the constant of variation. So this time, your task is to find the equation of variation. So to find the equation, let us determine first the constant of variation. So from here, our equation will be z is equal to k times w. So as for the constant of variation, k will be equal to z over w, in which it says in our statement, z should be equal to 50 and w should be equal to 40. Therefore, the constant will be 50 over 40. If we simplify this one, the answer will be 5/4. And this is the constant of variation. So after finding the constant of variation, let us substitute it to our equation. Therefore, it will be z is equal to 5/4 w. And this is the equation of variation. Let us have another example. Number 3. M varies directly as n. If m is equal to 3, then n is equal to 2. Find m when n is equal to 6. So it says here that m varies directly as n, which is equal to m equal to k times n. Next, to find the value of m, let us find first the constant of variation. So since the constant is equal to m over n, in which m is equal to 3 and is equal to positive 2. Therefore, the constant will be 3/2. After finding the value of k, let us now answer the second statement. Find m when n is equal to 6. So we will use this equation, substitute the value of k that we obtained, and the given value of n from our statement. So we have m is equal to 3/2 times 6. And 3/2 times 6 is equal to 18 over 2. Therefore, the value of m is equal to 9, in which 18 divided by 2 is equal to 9. And that is the answer. So let us have our last example, number 4. P is directly proportional to Q. If P is equal to 1/2, when Q is equal to 2/3, find Q if P is equal to 3. So this one is the same with our third example, only that the given are in fraction form. It says here that P is directly proportional to Q, which is in equation, it will be P is equal to K times Q. So, since they are the same, let us find first the constant of variation, in which the constant is equal to P over Q. So, therefore, from here, P is equal to 1/2 and Q should be equal to 2/3. Therefore, our constant will be 1 over 2/3. And remember that in some complex fraction, this one will be half times 3 halves. And 1/2 times 3 halves is equal to 4/4. And this is the constant of our function. Now that we are finding the constant of our variation, let us now find Q if P is equal to 3. So, using the equation P is equal to K times Q, we will substitute the value of K that we obtained and the value of P from our statement. So, we have P is equal to 3/4 times Q. So, to isolate Q here, let us multiply both sides by the reciprocal of 3/4, which is 4/3, in which this one will be equal to 1, and multiply 4/3 by 3. Therefore, we have 12 over 3, which is equal to Q. And 12 divided by 3 is equal to positive 4. Therefore, that is the value of. That's it for our tutorial. Thank you for watching. See you again in my next video. Bye!